In this session of Dezignworks TV, we're going to be working on an impeller. In this case, it's a closed one. So the first thing we need to do is create an alignment in Dezignworks. So on the Dezignworks toolbar, we're going to go up here and select the alignment tool. We actually have two types. We have an express and an advanced. We're going to use advanced. We're going to first select the base plane. This can be done by 3 points, or it can be done by multiples. So we selected the base plane. We're now going to define a direction. Again, this can be done by points, circles, edges, or spheres. We defined an X across the part. Now we're going to define a Y. And then now, in this case, the origin. On this part, the hub of this is actually been ground. So we're going to define this hub as the center of our part. We're going to use the circle center. He's going to take 3 points around the peripheral. You'll notice in Dezignworks it can be stored to the front, right, or top. This is Dezignworks 10 for Solidworks 10. Notice this is also stored in the feature tree. That way, if you lose power or actually have to do another part, you don't have to realign it. Let's go ahead and save this on our desktop. So the first thing we're going to do is pick the front plane and start a new sketch. For viewing purposes, notice in Dezignworks we have a for construction. We're going to use the arm to actually create a circle so we can view the part. Now, we want to find out what this profile is doing. We're going to utilize a tool called Lock Plane. In this case, we're not going to create any profiles. This tool allows you to create splines, lines, or points. We're going to actually take the arm and move it back and forth to grab the profile shape. So again, all you're doing is rubbing the probe against the part. A nice feature of Dezignworks is you can back up, overlap, stop, and start. What we're going to do is actually build this as a fully constrained profile. Then we'll go ahead and, for you Solidworks users, we'll actually just keep a closed profile and we'll revolve it. But again, this tool is great for capturing data that you want to make fully parametric. Or for freeform shapes, you actually can drag this and get a freeform surface. When the probe crosses that plane, it puts points or splines at that cross section. So now you can see as we rotated it, we have a nice cross section there. What we're going to do is make fully parametric models. This is just one technique. As a solid modeling user, there are different techniques. You actually could connect the points. Or you could simply drop data out there, and you're going to notice he's going to constrain this. Notice how they're horizontal and vertical. Then he can lock that to that. In this case, we know the bore is not on a taper. We knew it was straight. So we captured the data, utilized Solidworks tools to actually build a profile. Now notice here, this is more of a freeform shape. We could have used Dezignworks and captured that spline curve, but we thought it might be easier to constrain it. This is one of the nice things about a feature-based reverse engineering product, that you can make adjustments and changes. So now that he has all his geometry constrained, he's going to go ahead and trim it. Notice how you can interactively use Dezignworks and Solidworks simultaneously. Dezignworks tool is floating. You actually can dock it and put it where you want. In this case, we have it in the middle of the screen for easy use. Notice he now actually took the profile and used the Solidworks tool to revolve it. So you can see in this case, you can use Dezignworks in conjunction with Solidworks and build a model. Now that we have that profile, we're going to go ahead and work on starting to design the bottom of the vane. There's a flat surface as well as a concave surface. So we went ahead and we're going to take Dezignworks and use that lock plane tool in a very simplified format first. Remember how we built the profile? We're now kind of repeating that. We made a plane. We're moving the probe back and forth across it. When the probe pierces the plane, it intersects it and gives us data. In this case, we're going to use points, but we could have splines, and they actually are filtered. This is one of the nice things about Dezignworks. You can back up and overlap. Now that we have our profile, again, we could have used the curve tool, but we're going to go ahead and actually make this fully parametric. We're going to utilize the axis of the part to help build this bottom. In this case, if this is a freeform curve, we capture the data and we're going to use the curve tool in Solidworks to go ahead and complete it. The bottom of this is a cast, so it is very difficult to try to get that. It's kind of bumpy. But you can see, even if there were indents and imperfections in there, you can use Solidworks to pull this out. Now he's going to trim up his profile, revolve it, and we'll have the bottom shape of this. So we've got to revolve. Notice we have our base profile now. Now we're going to go ahead and determine where are these blades sitting in here. So we're first going to go ahead and be in a 3D sketch, and we're actually going to just determine where they're at in space. So notice he's going to take the probe and actually digitize in 3D space where this vein is at. In this case, there is an undercut area we can't quite reach with this current probe. Dezignworks does support bent probes. In this case, we would need more of a bent probe to get way back in this area. So we're going to be doing up to the undercut area. Notice how he captured a shape. Again, that was using Dezignworks in a 3D sketch, capturing the blade. And that's why we're using a point probe in this case. You could use ball probes, and Dezignworks does full compensation. But again, in this case with this blade, we want that very little edge. We're going to utilize a very, very powerful tool in Solidworks that allows us to actually fill a surface. Now, we captured the 3D profile and we can fill it. Now, for time's sake, we're not going to go in and actually verify it, but we would use the lock plane tool and put some planes through there and actually go back and forth up and down it. And we've already done this. And when we did, it was totally transparent. In cases where you need to pull the profile, you can use the 3D sketch in conjunction with other constraining data to manipulate that surface. But again, in this case, this freeform shape fell right inside that boundary.